Okay, let's do a quick summary then of the translations and dilations that we've done. So adding and subtracting is called a translation. That is a shift in position of the graph. If x is inside the function, that means we're going to be making a change in the left or right direction. So when we add a number inside the function, we actually shift to the left, and when we subtract a number inside the function, we shift to the right. When we deal with y, which is outside the function, if we add a number outside the function, it makes y shift up, the y values shift up, and subtract makes the y values shift down. Now, multiplying is called a dilation, which effectively stretches or shrinks the graph towards one of the axes, I should say. So a stretch or a shrink. So if we are inside the function, we are stretching and shrinking towards the y-axis or away from the y-axis. So if we multiply by 1, that actually makes our y values smaller in relation to y than they were before. So we are shrinking the graph towards the y-axis. If we multiply by a number less than 1, it's causing the graph to expand or stretch away from the x or the y-axis. If we are looking at our y value and we're multiplying by a number outside the function, it makes the whole graph stretch away from the x-axis, getting taller. If we are multiplying by the number less than 1, it's causing our y values to shrink towards the x-axis. Now, let's take a look at a couple of functions. I'm going to call this function number 1 and function number 2. And we're going to look at what it means to make a change inside the function or outside the function for a couple of different functions as examples. So a change inside the function, recall, that is a change directly to x. A change outside the function affects y. So we change inside the function. So let's say I want to add 3 inside the function. So f of x plus 3, that would be changing x in the denominator. So we put instead of x in the denominator, now we have x plus 3. For function number 2, let's say I want to multiply inside the function. So let's say I want to do f of 4x. So that would be 2 to the 4x power. So since the x is in the exponent position, I'm actually changing the exponent by doing a change inside the function. So the denominator here is inside the function. Here the exponent is inside the function. Just like when I did a square root, under the square root sign was inside the function. Now what if we want to make a change outside the function? So instead of adding 3 inside the function, I'm adding outside the function. That would look like this, 1 over x plus 3 outside the function. If I wanted to multiply outside the function by 4, it would look like this in function notation. It would look like this with the actual equation, 4 times 2 to the x. And using order of operations, it means I would do 2 to the power first and then times 4. This is not equal to 8 to the x. So be careful. All right, I'm going to put that in red. Be careful. We cannot combine those two together because 4 is not raised to the x power, only 2 is. Now, let's do a couple of examples, 3 examples. This is very similar to your homework problems. You have a homework that has a lot of different parent functions, each with 2 to 3 transformations, or actually 3 to 4 transformations to do afterwards. So the first thing you're going to do is draw a graph of the parent function. So my suggestion would be to make some sort of table of values for the parent function. So I'm going to actually just do it down here. I have a little bit of space. So f of x equals x cubed. So I'm going to just do x and y. With some functions, 3 key points are enough, but with a graph that has a curve and has both positive and negative values possible, I would suggest 5 values. I'm going to do -2, -1, 0, 1, and 2. So -2 cubed is -8, -1 cubed, -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So I'm going to use those 5 as my key points. So there's 1. So here are my key points. I'm just going to do these pretty quickly. and then I'm going to draw the graph. And I'm kind of doing it in red so you can still see the key points like that, but those are my key points. And the reason I need some key points is I can use those key points then to help me move the graph. So the first thing you do when you see a transformation is try to determine, is that transformation been done inside the function or outside? Well, my function is x cubed. So if I do something to x before I cube it, that's considered inside the function. So I'm adding 3 before I cube, that is inside the function. This would be the same as saying g of x is equal to f of x plus 3. So if I do f of x plus 3, then I would do x plus 3, the quantity cubed. Okay? So I have to think this is an inside the function, which means it affects x. It is adding, so that is a shift. And it's adding 3, so I'm going to actually shift to the left 3. So I'm shifting the whole graph left 3. So this is something that you need to get familiar with. Inside the function, if I add, it shifts the graph to the left 3. So I'm going to take each one of my key points and move it 3 to the left. And then redraw the graph. So that's why the key points are handy. It makes it easy to draw the whole graph when I'm just shifting a few points and then drawing the graph. So everything moved 3 to the left. Okay, so that's what we did here from the original graph. The next one is outside the function because I'm squaring 3, or squaring x, no, sorry, I'm cubing x before I multiply by 1/2. So this is a change outside the function, which means it's going to affect y. And then since it's a multiplication, it's going to be a stretch or a dilation, and it means y is going to be half as big. So y is half as far from the x-axis. So I'm going to take each one of my key points and make y half as big because I'm going to, so basically what I'm doing on this table of values is I'm finding x cubed and then I'm multiplying it by half. So instead of -2, -8, I would have -2, -4. Instead of -1, -1, I would have -1, -1/2. 0, 0 does not change. So if I plot these points, I have 0, 0, I have 1, 1/2, and I have 2, 1, 2, 3, 4. Okay, then I also have -1, -1/2, and -2, -4. So my graph looks like this. So that is the function now. So it's actually kind of moved it closer to the y-axis from both below and above. Or sorry, closer to the x-axis from both below and above. Okay, 2 more to do. This is also a change outside the function. You can clearly see outside the function. And it is subtracting. So it is a shift down 2. It's because it affects y. Since it's outside, it affects y. So it's shifting the whole graph down 2. So I take each one of my key points and move it down 2. So let me kind of extend the page up like that. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then kind of down here. I'm a little bit off the grid here with that one. There we go. So the whole thing shifted down 2. Last one is the trickiest one. This is a change inside the function. Inside affects x. And this is a dilation or a stretch. Now remember, anything inside the function ends up doing the opposite of what it looks like. Because remember when we were up here and we added inside the function, it actually shifted the graph to the negative direction. It shifted it left. And that is because of what we talked about with the translations earlier, that I have to compensate For example, to make y equal to 0, I would have to make x negative 3 instead of 0 to compensate for having added 3. So now I'm multiplying by 1/3 before times x before I cube it. So to get the same values for y that I had before, I'm going to have to compensate by making x 3 times bigger. So let's do g of x here. So if g of x equals 1/3 x to the 3rd power, so I've got x and y. Remember I suggested when I'm making a change inside the function, use the same values for y, but figure out what x has to be now in order to get those values. So to get 0, x is still 0. To get 1 for x, y, or for y, x would have to be 3, because I'd have to do 1/3 times 3 is 1, and then cube that. So this would be 3. To get 8 for x, this quantity would have to equal 2, so 1/3 of what would give me 2? X would have to be 6, because 1/3 times 6 is 2, and then 2 cubed is 8. And this would have to be negative 3 and negative 6. So notice that the stretch is, I'm actually getting points that are wider or farther away. So instead of negative 1 or negative 2, negative 8, now I have negative 6, negative 8. 1, 2, 3, 4, 5, 6, all the way down to negative 8. So I have negative 6, negative 8. Then I have negative 3, negative 1, 0, 0, 3, 1, and 6, 8. So my graph looks like this, which is 3 times farther from the y-axis. Or we could say 3 times wider. Okay, so that is how you do translations. Actually, I should say that is how you do transformations of various types, both translations and dilations, starting with a parent function. So just once again, to reiterate, draw the parent function identifying key points. Then decide whether or not the transformation is applying inside the function or outside the function, and whether if it's inside the function it affects x, if it's outside it affects y. If it's inside the function, it's going to actually have the opposite effect as what it looks like, and if it's outside the function, it'll be very straightforward, doing exactly what it looks like.